example, it says each box plot summarizes the number of miles driven each day for 30 days in each month. The box plot represent in order the months of August, September, October, November, December. The 5 box plots have the same median. Explain why the median is more appropriate for measuring the measure of center of the data set than the mean would be. So if we look at the dot plots of the box plots that we have here, if you notice that the median is the same, so it's actually 40 for all of them, so the middle number is the same, but they all look a little bit different. We want to know, why is the median better for describing the data than the mean? Well, if you notice, these are all skewed a little bit. They're not all symmetric, so that's why it would be the best measure of center. The next part says, arrange the box plots in order of least variability to greatest variability. So first we're going to talk about what is variability. Variability is how spread out your data is. So we have a few options for that. We have range, we have interquartile range, and we have a new one, which is mean absolute deviation, that we could look at. Now, since we are talking about the median as the measure of center, we're going to talk about the interquartile range as the measure of spread for this variability. So looking at the box plots, we need to find that interquartile range. So I'm going to find this, how far this box is. For example, in this one, it would be 60 minus 20, so Q3 minus Q1. And that would be an interquartile range of 40. So I'm going to go and do that for all of these. So now what I'm going to do is put them in order from least variability to most. So least variability would be the ones that are the closest together, have the smallest interquartile range. So E has 20, so that one's going to be the least. So I'll move it up here. And then we have 2 of them that have 40, so we need to look in a little more detail in that to separate between which is the better, which is the least. And then we have 50 and we have 60. So now looking at these 2 with 40, since they have the same interquartile range, but you can notice that there's not the same space spread out variability here, we can actually use the range to help us get more specific. So if you notice, this one goes from 80 to 10, so the range would be 70. And this one goes from about 62, it's a little hard to see, to maybe about 5 if we had to estimate to give us 57. So this range is smaller, so I'm going to say that this one comes before D. So now we're going to look at some dot plots, and these dot plots all have the same mean. I've actually gone through and marked the mean with the triangle here. It says, why is the mean more appropriate for measuring the measure of center than the median in these dot plots? So if you notice, all of these dot plots are symmetric. They're all shaped a little bit different, but they're all symmetric. So that's why the mean or the average is the better measure of center to use. Next, it says arrange the dot plots in order of least variability. So again, for variability, we have range, we have interquartile range, and we have mean absolute deviation. Whenever we're talking about data that is symmetric and we use the mean to describe the center, we're going to use the mean absolute deviation to describe the spread. So in order to find the mean absolute deviation for each of these dot plots, I would have to go in and actually draw the distance between each point and the mean, and then add up all those total distances and find the average distance. So this is going to take me a while to do. You can refer back to the mean absolute deviation video if you've forgotten how to do that, but it is going to take a little bit of time. So I'm going to go through and do those really fast. So now that I've found the mean absolute deviation, I want to find the least variability to the greatest. So the least would be the one that is the least spread out. So the least spread out is going to be the smallest number, because remember, mean absolute deviation tells me on average how far away are my points from the middle. So the smaller this number is, the closer they are to the middle. So if you notice, this one has a mean absolute deviation of 0 because all the points actually are exactly in the middle with the mean. So that one's 0. So I'm going to arrange the rest of these in order from smallest to largest. So I have these listed in order from smallest number to largest number. Be careful with your decimals and when you're using your place value in order to create those in the correct order. But we see that this one is the most inconsistent, and this one is the most consistent. here's a few other examples to get you thinking. This one says that two box plots have the same median and the same interquartile range. So how could we compare the variability if they have the same median and the same interquartile range? Well, if you notice, even though the interquartile range is the same and the median is the same, the total range is not the same. So we could use the range to describe the variability. We could also use the shape to describe the variability. So this one is a little bit more skewed because these data points are closer together, and this one has a little bit more symmetry going on with both ends of this box plot. In the next example, it says the two dot plots have the same mean absolute deviation. So how could we compare them if they have the same? So again, we could look at the shape. So the shape of this one kind of looks like this. The shape of this one is kind of bimodal. So we could compare the shape. We could also compare the range. This one goes from 1 to 9, and this one goes only from 2 to 8. Have a scenario where variability might help us figure out which option is best. It says a restaurant owner believes that it's beneficial to have different menu items with a lot of variability so that people have a choice of expensive and inexpensive food. Several chefs offer menus and suggested prices for the food they create. The owner creates dot plots for the prices of the menu items and finds summary statistics. Which one best matches what the restaurant is looking for? So remember, the restaurant is looking for a lot of variability in price. So let's study these dot plots a little more. So the restaurant owner didn't seem to care how much each person was spending in general. So that average and that middle number doesn't really matter with what the restaurant owner is looking for. We're looking for the spread or the variability of the data. And we want a large variability because he wants a lot of different menu prices on the menu. So if you look between our mean absolute deviation, our largest one is here. Between our interquartile range, this one is also our largest one. And if you look at the way that the data is shaped, you can see that the data is very spread out compared to some of the other options. So this second option, which is for Japanese food, would be better fit to what the chef wants for the restaurant.